Hello students, welcome back to the lecture series of continuity of functions, and this is our lecture number 6. So let's go through the video and please concentrate to the class. So this is your first question. Examine the continuity of the function fx is equal to 1 by x minus 1, fx is equal to x square minus 25 by x minus 5, and fx equal to mod of x minus 5. So these three questions, these are included in your main book. So let me take the question number B. So you see here, taking the question number B, fx is equal to x square minus 25 by x minus 5. So here in the question, it is not given at which point the function is to be check continuity is to be check continuous or discontinuous. That point is not given. That means if the question is asked for only 1 mark, then you are to directly write that this function is discontinuous at x is equal to 5, because you see the denominator, it is x minus 5. So this function is undefined if x is equal to 5, because 5 minus 5 will be 0, something divided by 0 will be equal to will be infinite. So that is why this entire function is discontinuous at x is equal to 5, and this types of question asked generally for 1 mark, just like the question is asked like this, at which point the function fx is equal to this one is discontinuous, or find the point of discontinuity of the function this. These types of questions generally asked for 1 mark in your final exam. But in this question, examine the continuity of the following functions. This function should be checked where it is continuous and where it is discontinuous. But if you take any point on the domain of the function, because domain of this function is nothing but this denominator, mean function is defined when x minus 5 this is unequal to 0. That means x is unequal to 0. So the domain is the set of real numbers r minus the point 0. This is the set of real number. Sorry, not 0, it is 5. It is 5, r minus 5. The point is r minus 5, not 0. Okay, this is not 0, it is r minus 5 only. Okay, so r minus 5 is the domain of the function. So if you take x is equal to a be any point in the domain of the function, that it will indicate that a is not equal to 5. A is not equal to 5, it will indicate this. So now just to check the function is continuous or discontinuous in the domain of the function, you just take a point x is equal to a, arbitrary point in the domain of the function, and as you take x is equal to a, then it is obviously that a is not equal to 5, because in the domain of the function the point 5 is not present. Okay, so we are going to take a point in the domain. So in that at that point the function is continuous or discontinuous, we will check that one. So first of all, I am erasing this. Just a minute. Okay, so we take x is equal to a be an arbitrary point in the domain of the function. Domain mean x is a is not 5. Then just find the limiting value of the function. X tends to a fx, this is your function. Then a x tends to a. Before finding the limit, we know the method. We are to simplify this function. So we are simplifying this. It is actually x minus 5 into x plus 5. So x minus 5 is cancelled, x plus 5 remaining, and using the limit, it is simply a plus 5. So the limiting value of the function is a plus 5, and to find the functional value, that is only fa, directly fa. So fa is equal to, it is a square minus 25, then a minus 5. Factorizing this, a minus 5 is cancelled, so it is simply a plus 5. And you see the left hand the limit of the function is a plus 5, and the function value is also a plus 5, so they are equal. Therefore limit x tends to a, fx is equal to fa, and so the function is continuous at x is equal to a. So therefore the function is continuous at x is equal to a. But what was a? You see here, a was an arbitrary point in the domain of the function. So but x is equal to a is an arbitrary point of the domain of the function. So the function is continuous at the domain, in the domain. Function is continuous in the domain. Mean function is continuous at all points except the point x is equal to 5. Except the point x is equal to 5, this function is continuous. But in all over the real number, all over the real line, this function is discontinuous at which point? It is discontinuous at x is equal to 5 point. But the function is continuous in the domain. Domain means x is not 5 already, and therefore this function is continuous in the domain but discontinuous at x is equal to 5. So that completes the solution of the problem. So next we take the problem number C. Next the slide is this. Examine the content. This is the question is same in the previous screen. You see this is solved, and now take this question, mod of x minus 5. So before solving these types of function having modulus sign, you may also use direct limit value and then function value. But in case a modulus point, a modulus function is given in the question, then it is very comfortable to eliminate the modulus sign before checking the limiting value or functional value of the function. So first of all, we remove the modulus sign. That means we express the function fx without the modulus sign. So we take the function, then fx is equal to, consider this x minus 5 total terms is equal to x. So it will be same if x minus 5 is positive, and it will be minus x minus 5 if x minus 5 is negative, by the definition of modulus function. You know this. Okay, so then the simplified line will be fx is equal to x minus 5 is there, and here it is x greater or equal to 5, and it will be, after multiplying by minus sign, it is 5 minus x, and where x is less than 5. So now this is our function, and we already solved these types of questions in the earlier videos. Here you see, for x greater than 5, fx is equal to x minus 5 is a polynomial function and it is a continuous function. In the similar way, when x is less than 5, then fx is equal to 5 minus x. It is again a polynomial function, and so it is also continuous for all x less than 5. So just the left out point is x is equal to 5, mean this one, x is equal to 5. So we are to check the continuity of the function at the point 5 only, because at all other points except this point x is equal to 5, the function is obviously continuous, because at those points the function is polynomial. So we write that here the possible point of discontinuity is x is equal to 5. At all other points the function is polynomial. You see, in this line and in this line, in both the lines the function is polynomial, so obviously they are continuous. So only the left out point is x is equal to 5. So it is continuous at all those points where x greater than 5 and where x is less than 5. We check the continuity at the point 5 only. So come here, at x is equal to 5, left hand limit is limit x tends to 5 minus fx. 5 minus means less than 0. This is less than 0. So fx is 5 minus x. Writing here, h is tending to 0, then 5 minus h. This x is replaced by x. X value is 5 minus. So 5 minus this h. X is replaced by 5 minus h. So after h is 0, it is 5 minus 5 equal to 0. So left hand limit is equal to 0. So similarly, the right hand limit tends to 5 plus. This is 5 plus x minus 5. Then x is replaced by 5 plus this h. 5 plus h. So in this case also h is 0, so will be equal to 5 minus 5, and that is also equal to 0. then these two values are equal, therefore we find the functional value also. So f5, that is x is exactly equal to 5, mean in the first line x is equal to 5 is also here. So here f5 will be equal to 5 minus 5, here is 5 minus 5, and so that is equal to 0. All the three values are equal, that is the function is continuous. So therefore left hand limit is equal to right hand limit is equal to the function value f5, as the function is continuous at x is equal to 5 also. The doubtful point was x is equal to 5, and we have seen here that the function is also continuous at the doubtful point, and that is why the function is continuous enter the domain of the function. Thus the function is a continuous function, and that completes the solution of the problem. Now we come to the next question. Find all points of discontinuity of the following functions. Similar type question actually. This is one of the function and this is the second function, and this is the third question. Come to this question. Fx is equal to 3x plus 7 divided by x square minus 5x plus 6. I told in the previous question, you see, actually whenever these types of functions are given, then first of all you see for which values of x the denominator of the function is 0, and at those points for those values of x the function will be discontinuous. But if in the question it is asked for domain, then obviously the function is a continuous function. Here you see, after factorizing x square minus 5x plus 6 will be equal to x minus 3. You see it is nothing but simply x minus 3 and whole into x minus 2, whole into x minus 2. This is the factorization of the denominator. And see here the denominator will be 0 when we take x is equal to 3 and when we take x is equal to 2. In these two cases the denominator of the function is 0, and that is why the function will be undefined at the point x is equal to 3 and x is equal to 2. So the function will be discontinuous at x is equal to 3 and x is equal to 2. But if the question asked for the domain, then you should write the function is a continuous function in the domain, because the domain of this function will be, you see here, the domain of the function just it is the set of real numbers but not the points 2 and 3. So 2, 3 will be eliminated from the real number, and this is the domain. So in the domain already the points discontinuous point is excluded, and therefore the function will be continuous at all points of the domain. Okay, so I am erasing this. So this question you can solve directly. You may write the function is discontinuous at x is equal to 2 and x is equal to 3. That is the answer for the question number A. Now the question number B, this types of question is already done and you can solve this question. I am going to solve the question number C. So C and B is of the similar type question, so I am going to solve the question number C. It is a question from your book. So fx is equal to, this is your function, and here again you see when x is less than minus 3 the function is a polynomial, because it is minus x plus 3 will be then the function will be minus x plus 3, and that is a polynomial continuous, and from minus 3 up to 3 fx is equal to minus twice x, and that is also a polynomial, so it is continuous. Similarly for x greater than 3 the function fx is always is equal to 6x plus 2, and that is again a polynomial, and so it is again a continuous function for all values. So the doubtful point here is points are only x is equal to minus 3 here, because at the point 3 less than minus 3 and greater than minus 3 the definition of the functions are different, so the possible point of discontinuity is minus 3, and similarly 3 is also a possible point of discontinuity. Except these 2 points the function is obviously continuous, because at all those points except these 2 the function is a continuous function. Okay, so we write the solution. Here the possible points of discontinuity are x is equal to minus 3 and x is equal to 3. At all other points the function is obviously continuous, as at those points they are polynomial functions. Okay, so now you just check the continuity at x is equal to minus 3. So at x is equal to minus 3, find the left hand limit, find the right hand limit, and find the function value. So left hand limit x tends to minus 3 minus, because left hand limit fx minus 3 minus mean less than minus 3 is this one, using here, and then making h tends to 0, so h tends to 0. X is replaced by 3 minus h, so we write here 3 minus 3 minus h. So then using h tends to 0, so it is modulus of minus 3 remaining there, so that is equal to 3, and plus 3 is here, so total value is 6. Then find right hand limit. RHL minus 3 plus, so greater than minus 3 is in this line, therefore fx is equal to, it is minus 2x, so we write minus 2x. Then limiting value is h tends to 0, so then this x is replaced by 3 plus h, we write here this will be 3 plus h, and then using h is 0, minus 3 plus h, and then h is 0, it is minus 2 and minus 3 product is equal to 6. So second value, second right hand limit of the function is also 6. So we have to check the functional value also at the point x is equal to minus 3. So f minus 3, directly x equal to minus 3 is in the first line, x is equal to minus 3. So the function should be taken as mod x plus 3, and mod x is replaced by minus 3 here, so minus mod 3, minus 3 mod, then plus 3, it is equal to 6. So all these three values are equal, that means the function is a continuous function at x is equal to minus 3. So we write that line. Therefore left hand limit is equal to right hand limit is equal to f minus 3. Hence the function is continuous at x is equal to minus 3. So we check the continuity at the point minus 3, then we check the continuity of the function at x is equal to 3. So this is the function, need not to write in your copy. So at x is equal to 3, again this time you find again left hand limit, right hand limit. So left hand limit x tends to 3 minus, mean less than 3. Here x is less than 3, so fx is minus twice x. So using the value minus twice x, then making h tends to 0, it is minus 2 into this is 3 minus h, here x is replaced, and so h is 0, it is minus 6 only. Then right hand limit x tends to 3 plus, now function is fx, 3 plus mean greater than 3, here is greater than 3, so fx is equal to 6x plus 2, we write here 6x plus 2, then h tends to 0, 6 into x is replaced by 3 plus h, this one plus 2, then h is 0, it is 20 only, 18 plus 2 is equal to 20. So they are unequal, mean the function is discontinuous. So therefore left hand limit is unequal to the right hand limit, hence the function is discontinuous at x is equal to 3. So this completes the solution of the problem. So thus the function is discontinuous only at the point x is equal to 3. We have actually two possible point of discontinuity, and at one of them the function is continuous, and the other point, at the other point the function is continuous. Okay, so next question. This is an important question actually. Is f at x is equal to 3, where fx is equal to, this is the definition of the function, where x is not equal to 3 given. So the question is whether this function is continuous at x is equal to 3. That is our first question. So if it is not continuous, then how can it be made so? That means this is actually a removable discontinuity. Actually the function is discontinuous, because from the definition of function here you see fx, x is not equal to 3, then fx is equal to this. So in the question it is not given for x equal to 3 what is fx, that is not given in the question. For x is equal to 3 what is fx, that is not given in the question. So that means at x is equal to 3 the function is undefined. Here, using x equal to 3 here also you can see the function is undefined, and that is why the function is a discontinuous function at x is equal to 3. That is the answer of the first question. If not, how can it be made so? That means it is a discontinuous function. So the next question is, how can we make this function continuous? That is our second question, and that is important part. So this question is actually a discontinuity of removable. So we come to the solution of the problem. First write that line. since the function is not defined at x is equal to 3, so it will be discontinuous at x is equal to 3. Very simple. So clearly, limiting value of this function, because x is not equal to 3 is given, mean we can find the limit value of the function. Limit value mean x tends to 3, it does not mean x equal to 3, it is actually x not equal to 3, therefore we can find the limiting value from the given definition of the function. So x tending to 3, function is this one, limiting value, it is factorization, a cube minus b cube formula is used here, and then x minus 3 is cancelled, so this term will remain, and then using x equal to 3, so it is 3 square, then 3 into 3 plus 9, so it is equal to 27. So if the function has the functional value is equal to 27, then it will be continuous, because we already observed that the limit value is equal to 27 and functional value mean f3 is also equal to 27, then it will be continuous function. So you see, therefore the function can be made continuous by redefining it as follows. The following definition, new definition of the function will be like this: fx is equal to, this is the given condition, so this is definition of the function, and this is the function value we have to take to make the function continuous. Now you see, if you take this question, forget about this total question, just think about this part. If you want to check the continuity of this function now, then obviously it is continuous, because when we find the limit value of this function, then we should use this line, and obviously the value will be equal to 27 here, and x equal to 3, that is f3 is equal to 27, so limit value is equal to f3, mean the function is continuous. So in this way, by redefining the function again, we can make the function as a continuous function. Okay, so that completes the solution of the problem. So next we take this question: find the values of a and b if the function fx equal to, this is the total function given, is continuous for all real values of x. We have already done this types of question actually, though we have done, I am going to solve this question for you. Okay, so take the solution. Since the function is continuous for all real values of x, it is continuous for all real values, and by the definition of the function, you see here the possible point of discontinuity are what? It is x equal to 2 and x equal to 5. These are the possible point of discontinuity, possible points of discontinuity. But in the question it is given that it is continuous for all real values, mean it is also continuous at the possible discontinuous point, mean 2 and 5. So we write that line. So for x is equal to 2, left hand limit and right hand limit should be equal. So limit x tends to 2 minus limit x tends to 2 plus should be equal, because it is continuous at all real value. So it will also be continuous at 2 and 5 also. So limit value f 2 minus mean less than 2, function is 1. So we using here greater than 2, 2 plus mean greater than 2, here is greater than 2. So fx is ax plus b, writing here, making h on the right side. This is one limit is 1, h tends to 0, it is x equal to 2 plus h is here, then plus b, then using h 0, it will be twice a plus b is equal to 1. Using that line, twice a plus b is equal to 1. Then take the point 5. For x is equal to 5, for this point, left hand limit and the right hand limit should be equal. So limit x tends to 5 minus x tends to 5 plus, these two limits are equal. So we use the values, 5 minus less than 5 is here. So fx taken by this line, and greater than 5 is this line, fx is taken as 5. So we write that line, this one, then making h on the left hand side, right hand side limit is 5 obviously. So limit h tends to 0, a is here, x is 5 minus h, then plus b is equal to right side 5, using h is equal to 0, so it is 5a plus b is equal to 5, 5a plus b equal to 5. Now just solve the equation number 1 and the equation number 2. Subtracting 1 from 2, 2 minus 1, you take b will cancel there, b will cancel there, then 5a minus twice is thrice a is equal to 4, you write this, 2 minus 1 thrice a is equal to 4, so a equal to 4 by 3. Then using this value of a either in equation 1 or in 2, you get the value of b. So I am using the equation number 1. So it will be 8 by 3, then plus b is there, plus 1 equal to 1, then b will be equal to 1 minus 8 by 3, this one. So it is equal to minus 5 by 3, and that is the completion of the solution of the problem. Next, this is our question. Find the value of k for which the function this one is continuous at x is equal to pi by 2. So again, pi by 2 point is given, and at this point it is continuous. That means the left hand limit, the limit value is equal to the function value. Need not to take the left hand and right hand limit, because the function is very simple function here, not given exponential, not given modulus function. So you can directly take the limit value and the function value. Okay, so take the solution. Since the function fx is continuous at x is equal to pi by 2, therefore limit x tends to pi by 2 fx is equal to f pi by 2, because the function is continuous. So x tends to pi by 2 means x is not equal pi by 2, and not equal to pi by 2 is in the first line, this one. So you write that one, and f pi by 2 means equal pi by 2, and in that case the function is equal to 3. So we write 3 here. Okay, then try to find the limit only. You see, the denominator's limit is equal to 0 after using x is equal to pi by 2 here, and therefore we have to take a simple substitution here by taking pi minus twice x as equal to some new variable, say y. You already solved these types of limits in the first year. So just take pi minus 2x is equal to some new variable. I am taking y here. So pi minus twice x is equal to y. Then when x is tending to pi by 2, then here y will be equal to 0. If you use x is equal to pi by 2, 2 cancel, so pi minus pi is equal to 0. So then you see x tending to pi by 2, then y tending to 0, and therefore this limit will be changed. So therefore 1 implies this k will come out of the limit, because it is a constant number, k is there. Limit x tends to pi by 2 will give limit y tends to 0. Then cos of x, cos is there, x will be here, the value of x, twice x can be shifted to the right hand side. It is pi minus y, then divided by 2. That means pi by 2 minus y by 2. And denominator is already taken as y here. Right hand side is 3. So taking 3. And so the numerator, you see, cos of pi by 2 minus some theta. Cos of pi by 2 minus theta will give us sin theta. You have the knowledge about the trigonometry. So cos pi by 2 minus y by 2 will be equal to sin y by 2. We write that. So k is remaining, y tends to 0. This is sin y by 2, and divided by y is already here. But if it is y by 2, then we have a formula. So I am writing here y by 2. This half is extra term here, and multiplying half here. And on the right hand side 3 is already there. Then that will imply k is here. This total limit value is 1. Then this half is already there. Right hand side is 3. So k will be equal to 6 only. And that completes the solution of the problem. Okay, next step. So this is your question. You see here the problem is find the value of a if fx is equal to, this is your given function, fx is equal to, this is your given function, is continuous at x is equal to 0. And this question is homework for you, and I am just giving hints for this question. You see here, actually this problem can be done by this way. We have a formula that limit of x tends to 0, x tends to 0, sin x, here the function is sin ax, you see, sin ax. So we write sin ax divided by ax whole square, because the given question having sin square here. And we take this a for the formula, and into here one extra term is taking a square. This a square you see here, this is a square, this is extra term. So you should multiply by that a square. This is a square, and that is equal to the function value. Function value is 1 here, you see, f0 is equal to 1. So you should begin with this line. Just you write, since the function is continuous at x is equal to 0, therefore this limit equal to 1, and then the limit should be converted to this line. Then here after this line you write, after this line this limiting value is 1, so it is 1 square, then you have a square, and on the right hand side is 1, and from here you will get the value of a as plus minus 1, and that will be the answer. And I think you can solve this problem yourself, and so I am giving this question as a homework for you. And now we take another question, and that question is like this one. I am erasing this. The next question is question number 22. Find the value of k such that the function fx is equal to, this is your function, is continuous at x is equal to pi. Here the concept is same. Since the function is continuous at x is equal to pi, and the pi point is the point of separation, because less than pi function is kx plus 1, for greater than pi function is fx equal to cos x. Therefore function continuous, therefore limit x tends to pi minus fx will be equal to limit x tends to pi plus fx. So we begin with that line. Since the function is continuous at x is equal to pi, therefore this is the condition for the function as a continuous function. Then using fx here, for pi minus mean less than pi, fx is taken as kx plus 1, and for greater than pi, fx is taken as cos x. So we write that line, this one, and then making it this limits in terms of h. So this is h tends to 0, k into x replaced by pi minus h, this is pi minus h, and here h tends to 0 and x is equal to pi plus this new variable h. Then using the limit here, you see, so it will be k pi only because h is 0, so k pi, this plus 1 is remaining same, and is equal to cos of pi only, and cos pi value is minus 1, and this one should be shifted to the right hand side, so minus 2 on the right side, and so k will be equal to minus 2 by pi. So I think you understood this question, and this is the end of the class, and next day we will take the last class of the chapter, continuity of function. So till then, thank you very much.